Good morning. Welcome to Concurrent session 4 on ecological study of raptors of the 12th Asian Raptor Research and Conservation Network Symposium. So I am Saiful Mansoor. You can call me Saiful, and I'll be chairing this session, which will run for 2 hours and 20 minutes. So there will be 7 talks, and every speaker will have 50 minutes for their presentation, and followed by 5 minutes for Q&A. So please stay within your allotted time to avoid any delays in subsequent presentation. Thank you. Without further ado, I would like to call the first speaker, Daniel E. Vollen from Coastal Raptors, Washington, USA. So he will be talking on Peregrine Falcon survival rates derived from a long-term study at a migratory and overwintering area in coastal Washington, USA. Okay, are you ready?
I'm ready. Can you hear me?
Yeah. Over to you, sir.
Okay. All right, well, it's a pleasure to be here. I want to start by acknowledging my co-authors, Larkin Powell, Joe Buchanan, Tracy Fleming, and Cheryl Vernier. And this study was initiated in North America on the Pacific coast. It's a study where we used bandings, resightings, and recoveries of dead birds to estimate survival and resighting probabilities in peregrine falcons. So on the Pacific coast, and here is a map of the United States, and specifically this was in Washington State on the southwest coast of Washington State. To the north is British Columbia in Canada, and to the south is the state of Oregon, and below that the state of California. So we banded birds, peregrine falcons on each leg. One leg received a U.S. Geologic Survey band that was either red or blue to denote the beach where the bird was banded. The other leg got a visual identification band that could be read from a distance without having to recapture the bird. And we used either a spotting scope that was attached by a window mount to the window of the vehicle, or we used a digital camera with telephoto lens. And in the later years of the study, we used the digital camera almost exclusively for resighting birds that we had banded during the course of this effort. So again, this was in Southwest Washington. We studied, we had 3 beaches that we drove over a period of years, Ocean Shores, Grayland, and Long Beach. And what we would do, we would drive and document the locations of birds and try to catch and band the peregrine falcons. And we used either a harnessed European starling or a rock pigeon as a lure. So the harness had attached to it slip knots out of fishing line to the back, and then to the front was a line attached to the front side of the vest that with a line that was maybe 10 meters long with a weight attached, so that if the bird grabbed, the peregrine grabbed the starling or pigeon, they couldn't fly off with it. And the hope is that they would get at least one toe caught in one of those slip knots. And we actually used pigeons much more often than we use starlings for this effort. As far as the data collection, the birds that we captured, there is the breakdown by gender in those birds. And then here is the breakdown by age class of the birds that we caught. So we estimated survival using the Cormac Jolly Zebra mark recapture model, and we used a program called Program Mark, which is available online for doing the analysis. This kind of analysis results in apparent survival rather than actual survival. Apparent survival is the likelihood that an animal survived and did not emigrate or leave the area. So this sort of output is unable to distinguish mortality from permanent emigration. In other words, birds that leave the study area and are not seen again, or seen by anybody anywhere, not just the study area, are counted as dead in the survival estimate. So we developed models to account for variation in survival and resighting probability based on 4 factors we looked at: gender, age at the encounter. We had 3 age classes, season, and time period. We had 2 time periods. So those three age classes were distinguished by plumage. Less than a year of age is these birds had the brown plumage of the immatures, and 1 to 2 year old birds then were the second age class, and they were in a transition between the immature plumage and the adult plumage, which is blue-gray. And the birds age 2 or older then have the blue-gray plumage of adults. So I mentioned we had two time periods that we looked at, tried to estimate survival using 2 time periods. So what we found as the years went on and as we looked at the data was there was a significant increase in the number of resightings of our marked birds by people not part of our survey team doing regular driving surveys on the beaches. And we attributed this to the advent of digital cameras in photography and telephoto lenses. Many more people out on the beach in the later years, and not just there, but other places where our birds went once they were banded, that were recorded by other people, and they either reported directly to us or to the US Federal Bird Banding Lab. So that was one reason why we divided the main data where we did to look at survival rate. And the other factor was bald eagles. We noticed that over the years, bald eagle numbers went up dramatically. And so that we wanted to see if that might have an effect on survival. So bald eagles are much larger, as you all know, and they are a mortality risk from predation to peregrine falcons. And they also, peregrines would compete with eagles for food, and eagles are known to commit kleptoparasitism, steal food from smaller raptors and actually each other eagles. I would say that over the many years of the study, we only saw this twice, and we got it on film. Here's one of the 2 examples here. You can see this peregrine, and this eagle came in and just grabbed its lunch there, so to speak. Well, moving on now to results and discussion. We did a total of 1,212 surveys over 22 years and 2 months. And these surveys, there were of 2 types. Complete raptor surveys were surveys where we had a definite protocol we used, and we had to have good weather with good visibility. And the data that was collected here could be used for certain kinds of analysis, like determining the number of birds observed per 100 kilometers driven, which is something I'm going to share with you just very shortly. Incomplete surveys were ones where we had, say, bad weather. We had to leave the beach early, or the tide came up, or we were out there for other objectives, other purposes. We didn't collect as much data, but we still might band birds. We still might recite our banded birds. So that's all part of the valuable information coming from the research effort. So this graph shows on the y-axis the number of surveys, and on the x the years of the study. Now it doesn't go to 2018 because we only included the first 2 months of 2018, and these are annual totals here. So the upper line, the black line, shows the cumulative totals number of surveys for the 3 beaches, and the gray lines below show the number of surveys by beach for the 3 beaches. And right away, you can see that in the second time period, far fewer surveys with a big dip in 2012 there. Well, that was because we started another study on the beaches where we were trapping eagles, ravens, and turkey vultures to look at contaminants and disease. And so we weren't doing our regular surveys. We weren't out as often during those years. Well, Program Mark found that in the second period, reciting probabilities were 73% of what they were during the first period, based on Program Mark. So now let's look at what the encounter rate of peregrine falcons was over all these years using the data from the complete raptor surveys. Actually, even though we were out there less often, we actually had no difference in the encounter rate of peregrines during those years, 3.5 during the early years and 4.0 per 100 kilometers driven in the later years, the last 10 years of the study. In contrast, number of bald eagles, the encounter rate increased significantly, dramatically over that period of time. And so now looking at the number of re-observations per year by Group A, which is our survey team, over the years of study, people directly involved in the research, no real difference, the total of, from the first period to the second. But Group B, again, those are the people out there that were not part of our group, but were citizen scientists and reported information to us, a dramatic increase there. So the differences between Group A and Group B are, the overall differences are reflected then in a significant difference based on a chi-square test. So this now shows the average number of banded individuals we observe per year. And we see the same thing there, that Group A, our group, while we've surveyed less in the latter years of the study, the second period, we still saw just about as many banded individuals, where Group B, the number was dramatically greater. Again, a chi-square test reveals the overall difference between the two is significant. So banding a bird is kind of like putting a message in a bottle. You get lots of interesting information as a result, and hear some very interesting people, and it's just kind of fun. Our birds were seen as far north as Seward, Alaska, and as far south as the Salton Sea in Southern California. And most of the birds, though, were seen on the Washington coast. 90% of the resightings were on one of our study area beaches. 10% of them were elsewhere in Washington or adjacent states, Oregon, California, Alaska, or British Columbia. So 47% of all of the birds that we banded were recited alive at least once, and that was 106 individuals. The total number of resightings we had over the course of the study was 744. One of our favorites is this bird right here, WZ, that was banded in 2007 and recited 22 times between 2007 and 2015. The bird was very approachable, and people got great photos of the bird over these years. And this, in fact, is another picture of WZ lifting off a piece of driftwood, a photo by Kate Davis. This one was used to create a painting by Hans Peters and wound up on the cover of the journal Raptor Research in September of 2020, where we had a feature article on this very study that I'm talking about here tonight. So if this morning for you, if you'd like to find further details, I encourage you to go to the journal Raptor Research, the September 2020 issue, and there's much more detail on the study itself. Sadly, WZ flew into a wire and died in 2015. That's not an uncommon cause of mortality among our peregrines. In fact, we had a total of 22 falcons found dead or disabled during the course of the study. By the way, birds that were found disabled were counted as dead, even though in most cases they were rehabilitated and released, because they would have died had they not been brought in to rehabilitate. But anyway, so collision with stationary object was first, and then you can see the rundown there of the other causes. Now to move on to the apparent survival estimate. Again, these were the models, the factors that we considered to look at through our modeling efforts. Only one turned out to be important, and that was age at encounter. And so time period, then neither bald eagles increasing or increased reobservations from group B were chosen in the modeling effort as important. So group B people were seeing pretty much the same birds we were as we were doing our surveys. So this then is the estimate of survival. This is what we got that turned out to be significant here. And as you would expect, the youngest age class had the lowest apparent survival rate, the highest among the older age birds. These are annual survivals, and the 1 to 2 year old bird in the middle there. So we were pleased with these results. In looking at this review article in IBIS from a few years ago, that was a review of survival rates in raptors and owls. Peregrine falcons, of course, were included, and our estimates were within the ballpark of those others. This is pretty good for the population we have, because our population is not year-round. It's a migratory population and an overwintering population. But it works well because many of our birds, WZ being one of the examples, show great site fidelity and would come back year after year. And many birds, especially in their early years, would actually even stay year-round on the study area. There's no nesting habitat adjacent to our study area. It's all north in northern Washington and beyond. We actually did a survival estimate in the early years of the study and published it in the journal Raptor Research also. And we found an annual rate for those years of 60%, no differences by gender, age class, or season. And at the end of that paper, we concluded that if we continued our studies, got more data, we might get a different result that would be show perhaps more clarity. And that's exactly what happened. So the first publication had far fewer years, fewer surveys, fewer banded birds, and fewer birds recited. And so it turned out pretty well for us. So we feel like our results show a high level of, reasonably high level of survival, suggesting good population performance in the peregrines. That, in connection with the steady encounter rates over the entire study period, bodes well for the species. It's a good news story for this species, which spent 25 years on the US endangered species list, but was removed due to great efforts across not only the United States, but Canada to reintroduce birds. The culprit, the reason for the decline was almost exclusively because of eggshell thinning from DDT. And Rob Palmer, or Rob Beauregard from Raptor Research Foundation talked about that in his plenary yesterday. So there were peregrines reintroduced across North America, over 6,000 over several decades, that brought the bird back and recovered it. So it's really a good news story, and it was a very a long-term monitoring over 20 years, that has a good result and something that is very positive. So I'm done, and if anybody has questions, if we have a little more time, I'm happy to try to answer them.
Great. Thank you so much for a great sharing and presentation, Dr. Valen. So maybe we have 3 minutes for Q&A. Okay, any question from the audience? Please feel free to put your question in the chat box, or you can unmute yourself. So I can see any question in the chat box.
Anything in there?
If no question, maybe I have, okay, we have one question for you here in the chat box. Good morning. Okay, from Jilan Gan. Good morning. I am curious about your capture method. Does the pigeon and bat die in the process?
Yes, often they do, but these are invasive species in North America. They are not protected. It's legal to use this method. They were introduced both from Europe, and so it's possible to use these. We cannot use native species.
Okay. Any other question? So we have 1 minute. Okay, maybe I have one question for you.
Sure.
So as we know that the current population trend is increasing and stable now, so is there any possible that they will compete with other native raptor species, the smaller one?
Well, yes, like merlins, for example. I am seeing fewer merlins on the beach. That's one of the species that we count and document. And I actually know a researcher that in another part of Western Washington has documented a clear trend of fewer merlins as the peregrines have moved in and increased. So it can happen. Yeah.
Okay. Okay, thank you for the answer. Any other question from the audience? If no more question, I would like to thank Dr. Valen for a very interesting study and your presentation. Thank you very much.
Okay, thank you. All right, so I'll stop the share here.
Okay.
Okay.
Okay. Okay. Now. Okay. All right. Okay. Now let's move to our next presenter. Nur Adibah Ismail from University Kebangsaan Malaysia. So she will be talking about assessing the diet of the Black-thighed Falconet, Microhierax fringillarius in Peninsular Malaysia. Adibah, are you there?
Yes, can you hear me?
Yep.
And can you see my
Yeah, I can see your slide.
All right.
You can.
Okay.
All right.
Okay.
Okay, the floor is yours.
Assalamualaikum and a very good morning to everyone. I am Nur Adibah Ismail. Today I would like to share with you a research project entitled Assessing Diet of the Black-thighed Falconet in Peninsular Malaysia. Okay. Next is a little bit introduction on the subject study. The Black-thighed Falconet, or also known as Microhierax fringillarius, is one of the smallest bird of prey. In fact, it is the smallest raptor in the world. Their size is typically measuring between 14 to 16 centimeter long, with a range of 27 to 32 centimeter wingspan in length. For comparison, their size is comparable to a typical sparrow. For their distribution, it is native to Brunei, Myanmar, Thailand, Malaysia, Singapore, and Indonesia, and it is considered vagrant to Sri Lanka. Okay. Next, we are moving on to the problem statement of this study. Many studies has been carried out on the raptor ecology, but mainly focusing on breeding, biology, and migratory activity only. Not much study conducted on their diet preferences, particularly in Peninsular Malaysia. Additionally, in raptor study, data collection based on the direct observation is often time-consuming. Thus, in order to save time and cost, the method of assessing diet preferences by conducting identification of uneaten prey remains or the analysis of the regurgitated pellet can be used. Okay. Next is the importance of this study. Identifying the composition of avian diet is a critical step in characterizing the role of bird within ecosystem. In addition, the study also enable an understanding of how energy moves across ecosystem. Okay. The main objective of this study is to determine the diet preferences of the black-thighed falconet, and the early hypothesis met in this study is the method of morphological identification used to assess diet preferences of the black-thighed falconet is the suitable method that can be used to aid in the diet determining process. Okay. Next, we're moving on to the methodology. Okay. As you can see here, is the map of the Peninsular Malaysia. The red dot mark on the map indicate the sampling site, which located in the northwest peninsula at Ipoh, Perak. Okay. The sampling activity was carried out from February to September 2017. All right. For the pellets collection and direct observation, the pellet samples and prey preferences were collected and observed directly from their roosting area. And as you can see here in the picture, is the roosting area of the black-thighed falconet mentioned in this study. Okay. For the diet identification, all prey fragments were identified using a stereo microscope, and the picture attached showing the microscope used for this study. Okay. Next, we moving on to the result discussion. Okay. First is the prey identification by direct observation. Okay, as you can see in the picture attached, that shows an individual of black-thighed falconet is eating the prey, which seen here like a small bird. Additionally, the black-thighed falconet also observed eating other prey such as the bat and houseweed, which they caught in the middle of the air during flying. And they also devour reptiles such as house gecko, insects such as bee, dragonfly, butterfly and moth, and also other small birds. Additionally, they also eat small mammals like rat. Okay. Next is the prey assessment by morphological identification. As you all can see here, the picture shows some of the pellets dropping collected for analysis. The pellet is on the left side, whereas the rest is the uneaten prey fragments. Okay. Most of the samples fragment identified is composed of three major components that leads by exoskeleton at 15.3%, then followed by wings fragment at 27%, and finally is the unidentifiable element at 20%. Okay. Next, the most often discovered body part were the head, elytra, body segment, leg and wings. The prey morphological identification method only allow us to assess the prey to their order level, and there are a total of 6 order of prey altogether that managed to be identified. First is Coleoptera with a proportion of 30.43%. Next is followed by RNA with 21.74%. The third one is Blatodia with 17.39%. Orthoptera and Hymenoptera carries the same amount of proportion at 13.04%, and lastly is Manthodia at 4.35%. Next is the palate measurement. The mean and the standard deviation value for the length is 15.55 plus minus 6.02 millimeter, and the width of the palate is 7.87 plus minus 2.74 millimeter. Okay, for the dry weight measurement, it is usually ranging from 0.01 to 0.32 gram, with mean and standard deviation value of 0.16 plus minus 0.06 gram. All right. Next is some of the sample picture observed under the stereo microscope. The first and the second picture were identified as Hymenoptera fragments, and the third and fourth were identified as the water beetle fragment. Okay. Next is the picture of Scarabidae fragment, and this is the spider fragment. Next one is also the picture of spider fragment, and this is the head part fragment of the Hymenoptera, and the last one is the mouth part of the Orthopteran. Okay. Not much prey can be observed and identified using the direct observation method, as the time is limited and the chances of seeing any individual delivering the prey also is low. Okay. Additionally, the distance of observer from the individual to identify their prey, as the view to observe is not always clear. Right. Alternatively, the morphological identification method can help to further identify their diet, but it is limited at the order level of the organism only due to incomplete fragment of the prey individuals. Okay. However, most of the prey observed during direct observation were not detected by morphological identification due to complete digestion of the prey soft tissues, which leaving behind the remaining hard fragment in the pellets. Okay. As a conclusion, this study helps to give insight on the diet preferences of the Black-thighed Falconet. The method of prey morphological identification helps to determine the prey eaten by the Black-thighed Falconet. However, it is limited to their order level only due to incomplete fragment, as most of the prey soft tissues has already been completely digested, which leaving behind only the hard part, such as the exoskeleton. Thus, I think comprehensive dietary studies and additional methods such as molecular technique are needed in order to increase the proportion of prey identified. And for your all information, we are already planning to study this Black-thighed Falconet diet using the modern technique of next generation sequencing, as it can aid in detailed screening of the prey and can increase the chances to identify them to their species level. Okay. Next, I would like to thank Ministry of Higher Education that provide funds for the study. Okay, so that's all from me. If you have any question, you can reach me at my email or you can type it on the chat box provided. Okay, thank you.
Okay. Thank you, Adibah, for your presentation. Now I would like to open the floor to question. Okay, we have 2 questions for you in chat box. So first question come from Ashok Verma. So how easy it was to collect pellets and how many at a time? Thanks. Adibah, you there? Please unmute your mic.
Hello.
Hello, okay.
I can hear you.
Yeah.
Wait.
Okay. Okay, you can answer the first question from Ashok Verma.
Right. Okay. Right. How easy to collect? Okay. All right. I will answer the Ashok Verma question first. It is quite easy as we only need to use a pair of forceps, but it depends on the location of the dropping. So I think if the dropping is at the lower side of the roosting area, it will be much easier for us to collect the fecal sample. Okay, is that answering your question, Ashok Verma?
Hello.
Okay.
Can I?
Yes,
Alright.
please go ahead.
Yeah.
Okay, and
So actually, it was very difficult in case of harriers. So I just wanted to know, was it easy to collect the pallet, and how many numbers? I'm not getting the answer.
it depends on the quantities depend on how much at that current time, at how much is dropping excreted by the black-thighed falconet at that current time during the sampling time. So
Meaning we collect
it is
as
quite
much
easy.
as possible, eh?
Yes. For Amirama.
Okay, next question by Amira Rama.
How high was the
Can
quite high, but the dropping that we collect is on the ground, so it is not influencing our sampling activity, but the nest is quite high.
so you mean the fecal drops on the ground, eh?
Yes.
All right. Okay. I hope that answer the question. I think I would like to thank Adibah for your presentation. So I wish you all the best to further this study in molecular means.
All right. Thank you.
Okay, now let's welcome our next presenter. Riri Wiyanti Retnanintias, okay, who will be speaking on reviewing the current distribution of Javan Hawk-Eagle, Nisaetus bartelsi, okay, study involving citizen science data from Burungnesia database. Riri Wiyanti, are you here?
Yes, I am here.
Okay, you can now share your slide.
Thank you.
Okay, the floor is yours.
Thank you. Let me share my screen. Can you see my screen? Okay.
Yes.
Yes. Very good. All right. Good morning, everyone. My name is Riri Renaningtias, and today I am speaking on behalf of Burungnesia and Woodpecker, a citizen science center based in Malang, East Java, Indonesia. And today I would like to share about our current ongoing project on the review of the current distribution of Javan Hawk-Eagle, Nisaetus bartelsi, using Burungnesia citizen science data. First of all, I would like to thank my coworkers, including Fitriana Saleha, Milenia Luna Amika, Waskita Kukuvibowo, and Triswinasis Bagus Prabowo for making this happen in the first place. Working with wildlife is working and racing against extinction. Thus, monitoring biodiversity is a crucial part of conservation endeavors, because species shift their distribution and phenology to respond to their changing environment, such as climate change and other anthropogenic stressors. However, the direction, timing, and magnitude are hard to measure. Therefore, metrics are needed to quantify the contemporary ecological requirements of species to support the management strategies. Indonesia is an archipelagic country, and spatially segregated landscape of an archipelago usually give rise to high rates of endemism. And this high rate of endemism can be seen from the high numbers of species diversity, including birds, and this applies to majority of Indonesian islands, including Java and eventually Bali. Java and Bali is one of the biodiversity hotspots because these islands represent regions with the highest, highest rates of development, Bali being the center of tourism activities in Indonesia. Java is known for a long history of cultivation since 1000 AD approximately, and it resulted in habitat loss and fragmentation, apart from the fact that archipelagic country is a naturally fragmented habitat in the first place. Therefore, with a lot of pressure from people, especially from humans, local extirpation keeps occurring, and it is growing in numbers, pressuring wildlife further deeper into the jungles, combined with illegal wildlife trade and climate change. And one of the most affected wildlife, or form of wildlife in Indonesia, is the national bird itself, the Javan Hawk-Eagle. This species is distributed in Java. Historically, it is known that, as the name implies, Javan Hawk-Eagle is distributed mainly in Java. However, our current data suggested that this species is now distributed across Java, Nusa Barong, a small island in the south of East Java, and Bali, according to Burungnesia. This species inhabit primary and secondary forests from lowlands to highlands and mountain areas, and it is declared as national bird of Indonesia due to its resemblance to Garuda. However, this race of status has created such kind of paradox because the most protected birds in Indonesia is apparently the most vulnerable and the most endangered bird in Indonesia as well, because it is threatened by habitat loss, fragmentations, climate change, and illegal wildlife trade. This is why this species has been the main focus of conservation endeavors in Indonesia. Studies are focused on this species and many studies has attempted to map their spatial distribution as well as their potential habitats of Javan Hawk-Eagle using terrestrial survey. However, this kind of survey is somewhat problematic in terms of it is simply difficult to do because it requires enormous time, fund, human resources due to the vastness of Java itself and its difficult terrains, not to mention the silent forest phenomena that also constrains the physical monitoring for these species. Therefore, another approach to map or to monitor these species are proposed with the advent of technology. People now use GIS, and one of the most, latest approach is using the citizen science data to bridge the gap between the lack of empirical data due to research. It is simply impossible to map all across Java in one time for one species. Therefore, citizen science data, however, citizen science data can cover large spatial areas, including the ones in remote areas and previously unexplored areas, because the data are obtained or taken by grassroots citizens, by everyday people, and it can be done in synchrony from across Java in real time. And with this data, rigorous studies on wildlife with robust results are possible. One of the movements of citizen science in Indonesia is Burungnesia itself. It is founded in 2016 by Birdpecker, and Burungnesia mobile application, is a birding note and field guide within 7-inch. People can download it on Play Store. It has field guide containing over 436 species with over 750 photos, and we can also checklist everything that we see through this application and export the data to the database. And the database is open for everyone, especially the users, to download for their anything that they want to use it for. So far, by 2021, Burungnesia has been downloaded over 6,000 times over the course of 5 years, with 2,000 members and over 30,000 plus checklists, with in average 15 checklists per day. With this such massive movement, it is possible to map Javan Hawk-Eagle or to collect data of their occurrence across Java with a more with this massive data, it is closer to reality. And numerous studies have been conducted to map this and model the species based on their predictions generated from their ecological needs. However, these studies focus only on regional extent, while studies that cover larger extent remain elusive. So far, one study has conducted by Nur Samsi and friends covers all over Java to model the distribution of Javan Hawk-Eagle based on prediction using maximum entropy. And the results suggested that Javan Hawk-Eagle is mainly influenced by elevation and annual mean temperature. Sorry. However, there are some things to consider here. As new records on distribution has been recorded in Bali and Nusa Barong, an update in distribution map and ecological niche models are needed to delineate the potential distributions of Javan Hawk-Eagle. And Burungnesia is currently constructing a species distribution model using ensemble method to delineate their potential distribution, their habitat and their potential habitats according to the current and latest data. Here is the data, the occurrence data gathered by citizen scientists across Java and Bali from Burungnesia contributors. We can see in this video from 2016 and until 2021. And we can see here that the points are growing. And it simply shows that Javan Hawk-Eagle can be frequently seen in the mountains and in lowlands. In mapping distribution, we propose to construct ecological niche modeling. This is actually an ongoing research. So today, I'm going to share part of this project. We use generalized linear model using presence data to estimate the relationship of Javan Hawk-Eagle and their environment, to delineate extent distributions and extrapolate their potential habitats based on their ecological niche. Therefore, this study aims to report the current distribution of Javan Hawk-Eagle based on the latest records, and to construct ecological niche models for Javan Hawk-Eagle to describe the breadth and extent of this model interpreted from conditions inherent to the current distribution. To construct the model, we use 19 bioclimatic variables with 5 minutes resolution and physiographic and demographic variables, such as elevation, population index, and NDVI. The occurrence points were derived from Burungnesia Citizen Science Database, and we obtained 237 presence points that are reduced to 68 for using spatial thinning for the purpose of analysis. And the pseudo absence were randomly sampled within 25 kilometers buffer area with presence points excluded. Here is the current distribution with, as I highlighted before, there are some new records in the lowland forest at Nusa Barong Island, here in the southern part of Jember here, and one location in Bali. To adjust the model, we use Spearman correlation coefficient to gauge highly intercorrelated variables, and the initial predictors were selected before fitting multiple predictors into the GLM, and most important variables were selected based on their AIC scores. The result of this process is the most important variables that is integrated into the model, namely elevation, precipitation of the wettest quarter, precipitation of the warmest quarter, and the temperature annual range. The model is constructed with polynomial terms with stepwise procedure to select the most important variables based on their AIC. The results suggested that the models explain 10% of the deviance. And then the model is evaluated using AUC, or area under curve, as well as the true scale statistics. The results suggest that the partial response plots of the general linear model indicates a higher probability of occurrence for Nisaetus bartelsi, given a higher elevation, a higher value of precipitation of the wettest quarter, bio 16 in here, and lower precipitation of the warmest quarter, bio 18 in here, and low temperature annual range, or bio 7. The GLM prediction, I'm sorry. The GLM prediction suggested that, as we see here, the highest concentration of occurrence appears in the central part of Java. This particular part of Java is composed from a range, mountain ranges, and as well as the western, we can also see the higher probability of occurrence in the western part of Java and a patchy distributions in the mountains along East Java, as well as a low to moderate occurrence probability in the mountainous areas in Bali. And this map is then translated into binary prediction for us to see it more easily. And we can see here that Javan Hawk-Eagle is probably occur, because this is the occurrence probabilities, mainly occur in the central part of Java, some part of the northern coast in here, of central Java, southern part of West Java, patchy areas in this southern part of west and center. And the problem is here because in East Java, they are only found in higher elevations, in the mountain areas. And these habitats are not really connected to one another.
Sorry to interrupt. You have 1 minute.
Okay, thank you. All right, I will just, so this, from that model, we can see that this species is distributed in higher elevations with higher precipitations. And this result is actually congruent with the previous studies that reported Javan Hawk-Eagle is primarily distributed in primary forests of mountain areas with preference for close shrubs and forested areas. However, this study has some limitations. The ecological niche model displayed predictions based on fair to poor AUC scores, and the model projections cannot ignore uncertainties such as the interplay of bioclimatic variables and the species response, the interaction of species, as well as other anthropogenic pressures. And the predictions were also based only on elevation and climatic variables. To produce more comprehensive and realistic model, we need more data, especially in the wildlife trade, to produce more, wildlife trade, because wildlife trade is the main threat for Javan Hawk-Eagle in the present days. To conclude, Javan Hawk-Eagle is distributed across Java, Nusa Barong, and Bali per Burungnesia data in 2021. And the most important variables that affect their occurrence being elevation, precipitation of the wettest quarter, and precipitation of the wettest month, and as well as the temperature annual range. The ENM suggests that this species is distributed in higher elevations with higher precipitations and low temperature annual range. I would like to thank Burungnesia and Birdpacker and all Burungnesia contributors, because without these data, without all those citizen science all across Indonesia, this research would not be possible to happen. Thank you very much. I'm really open for suggestions and questions. Thank you.
Okay, thank you so much, Riri, for great presentation. So since we are behind the schedule, maybe those who have questions can write the question in the chat box. Okay. So maybe Riri can answer in the chat box. All right. Now let's move to our next presenter, Fritiana. Saleha, okay, who will be talking about habitat suitability modeling of Sunda Scops-Owl, Otus lempiji using Geographic Information System in Java Island based on Burungnesia citizen science data.
Okay, thank you. I will share my screen.
Okay, the floor is yours.
Can you see my screen?
Yes.
Okay, thank you very much for the chance. Good morning, ladies and gentlemen. I would like to introduce myself. My name is Fitriana Saleha. I'm from Backpacker, Indonesia. So I would like to present our research about habitat suitability modeling of Sunda Scops-Owl using Geographic Information System in Java Island based on Burungnesia citizen science data. Nowadays, it's very important to monitor biodiversity for conservation purpose due to climate change, land conversion, wildlife threat, and others. So it will have an impact on distribution and phenology of species, which is hard to measure. Therefore, metrics are needed to quantify contemporary ecological requirements of species. Urban areas is interesting because urban areas face an extreme land use and habitat changes. The reason why this research focus on Java Island because this island has a highest rates of development. From the history, Java is known of cultivation and deforestation since 100 AD. In fact, Java Island have been homes to endemic species, including avian biodiversity since the Pleistocene era. Birds have an important role in ecosystem, especially in urban ecosystem. Birds are sensitive to environmental changes and most impacted taxa by urbanization. Birds are ideal to as parameter for knowing human activity effect, especially in urban area. So far, this taxa can survive from anthropogenic pressures in urban landscape. However, there is still no studies and empirical data that can support this claim, especially in Java. Sunda Scops-Owl is common owl in Sundaland. The species live cosmopolitan and have tendency to live in urban areas. However, there is no empirical data that supports that claim. So a deeper insight on distribution and their habitat suitability is needed. According to Locke and Friends, this paper, The Biology of Sunda Scops-Owl in Singapore, about emphasize the biology of Sunda Scops-Owl in Singapore. This paper suggests Sunda Scops-Owl seem to be attracted to live near humans. However, empirical data supporting this notion remains elusive. So the objective this research is construct a habitat suitability model for Sunda Scops-Owl and describe the breadth and extent of their distribution based on the condition inherent to the extent distribution. In doing so, we prepare tools and materials to construct Maxent model or maximum entropy. We use occurrence data derived from Burungnesia citizen science database. We also use environmental data such as bioclimatic, elevation, vegetation, human population, wetlands, and water bodies. We use ArcMap from ArcGIS and maximum entropy to generate the model and analyze the data. Data analysis is involved model validation and descriptive analysis. To bridge the gap between the lack of empirical data and the need of quantify temporary requirements of species, citizen science data offers a solution. Citizen science data cover large spatial areas, including the remote and previously unexplored areas, because the data are obtained by grassroots citizens. With this data, rigorous studies on urban wildlife with robust results are possible. Of course, to be able to accommodate data from citizen science, we need something that can be used as a notebook and field guide in one hand. Burungnesia is a citizen science application that can input bird checklist data, field guide, and also can export data from user observation. So here the state of Burungnesia by 2021. Burungnesia has been downloaded over 6,000 times over the course of 5 years since its foundation in 2016 over 2021. And the important is total individuals have been recorded over 1 million. Okay, this is an encounter point Sunda Scops-Owl in Indonesia from 2016 until 2021. We can see the point is growing from time to time. The point reached Sumatra, Borneo, and the most many point is in Java Island. I would like to highlight Sunda Scops-Owl data in Burungnesia. The total number observed in 2016 until 2021 was 412, as many as 230 checklists were reported. There is the first record on Natuna Island, one checklist with 2 individuals observed. There is only one checklist with more than 10 individuals. 20 in Madiun, East Java. Most are found in urban, suburban habitats, gardens, rice fields, secondary forests, peatlands, and coastal areas. Results and discussions. The model suggests that human population affect Sunda Scops-Owl distribution in Java Island with a 40% contribution compared to other variables. Environmental variables that affect is human population, elevation, and vegetation. So here's the jackknife result, suggests that human population has highest value, 0.3. AUC from jackknife show that human population is important variables from this prediction model. So here's a distribution prediction map of Sunda Scops-Owl in Java Island. We can see the most red area almost covers urban areas such as Jakarta, Cirebon, Yogyakarta, and Malang. So here's another diagram from Maxent result. Assessment of accuracy for each variable in the model is measured by the area under curve or AUC. The minimum standard of acceptable model accuracy and performance is when the random prediction value reach above or equal to 0.5 or AUC 0.5. Habitat model was robust with AUC value 0.856. In conclusions, the model suggests that human population affect Sunda Scops-Owl distribution in Java Island, and this result support that the species have tendency to be near urban areas with a 40% contribution compared to the other variables. The most important environmental variables are human population, elevation, and vegetation. And the suggestions is this model only describes what variables have an effect on the distribution Sunda Scops-Owl without explaining the interaction between variables and between species, and also the uncertainty factors that occur from these interactions. And more continuous data is needed to produce more realistic and accurate results. And the last, in the future, climate change data needs to be integrated into habitat suitability models. I would like to say thank you so much for Backpacker Indonesia, Burungnesia, and all contributor Burungnesia that can make this research possible. Thank you very much for your attention. I will return to the moderator. Thank you.
Thank you so much for your presentation, Pritiana. It's good to have a local citizen science data database. So now I would like to open the floor to question. Any question from the audience? You can write your question in chat box. Okay, you can unmute yourself. If no question, anyone? If no question, maybe I have one question for you. Okay, based on your finding, you're saying that human population factor affected the most on the occurrence of the species. Am I right?
Yes.
So does it mean higher human population will have higher Sunda Scops-Owl, or the other way around?
I cannot make sure because this only prediction about occurrence Sunda Scops-Owl in Java Island.
Okay, okay. So we have one question for you in the chat box. Okay, from Yen Yilu. So apart from human population, what other factors were important?
From the results model predictions, the other factors were important is elevation and vegetation.
Okay. Okay, I hope they answer your question. So any other question from the audience? Okay, if there no question, I would like to thank Pritiana Saleha, okay, for the presentation. Okay, now let's move to our next presenter, Ashok Verma, okay, who will be talking on the winter ecology of Pallid Harrier Circus macrourus in northwestern India. Okay, Mr. Verma, are you here? You can now share your slide. Mr. Ashok Verma.
Sorry to interrupt, Dr. Saiful. I think Mr. Ashok Verma is not in. So perhaps we can move to the next presentation first, and then we come back to Mr. Ashok.
Okay, let's move to the next presenter. So I think the next presenter is a recorded presentation, right?
Yes, it's a pre-recorded presentation.
Okay, okay. And it will be presented by Radhika Jha from India. So we'll be talking on habitat projection for conservation using species distribution models, a case of globally threatened Egyptian vulture in northern India. Okay, I think we can start. Can start play the recording.
Good afternoon. My name is Radhika and I am a research scholar at the Department of Zoology in the University of Lucknow. Currently, I am working in the field of vulture habitat ecology, and today the topic of my presentation is
Đâu sao? Still no sound.
Maybe the tech team can help. Okay.
Good afternoon. My name is Radhika and I am a research scholar at the Department of Zoology in the University of Lucknow. Currently, I'm working in the field of vulture habitat ecology, and today the topic of my presentation is habitat projections for conservation using species distribution models, a case of globally threatened Egyptian vulture in northern India. The area chosen for this study is Uttar Pradesh, which is a state in northern India. Uttar Pradesh has a subtropical dry winter climate. The average annual temperature ranges from 5 degrees Celsius to 45 degrees Celsius, whereas the average annual precipitation ranges from 1000 to 1200 millimeters. On the map on the left, we can see that Uttar Pradesh is largely an agrarian state, which is depicted by the yellow color. It has small patches of forests in the northern and the southern part. These lines indicate the different rivers that flow through Uttar Pradesh, and these red areas indicate built-up area, which are the major cities in the state. Uttar Pradesh has been divided into 4 ecozones based on climate, topography, and vegetation. The first, shown in green color, is the Vindhyan-Bundelkhand ecozone. This is classified by high temperature, low rainfall, tropical dry forests, and undulating terrain with cliffs. The second ecozone, shown in blue color, is the Gangetic ecozone. This is the river basin of the river Ganga and its tributaries. This is largely a fertile alluvial plain and has little or no forests in this area. The third zone in the color red is the Tarai ecozone. This is marked by high rainfall, lower temperature, tropical moist forests, and a flat terrain. Finally, the fourth ecozone is the semi-arid ecozone marked in the color yellow. It is classified with low rainfall, high temperature, tropical thorn forests, and ravines. Uttar Pradesh is home to 8 species of vultures. 5 are resident. These are Egyptian vulture, Indian vulture, red-headed vulture, slender-billed vulture, and the white-rumped vulture. 3 are migratory. These are cinereous vulture, Eurasian griffon, and Himalayan griffon. They only visit this state in the winter season, which is roughly from November to March. Of these 8 species, Egyptian vulture is known to be the most ecologically plastic species. It is also the most abundant vulture species in terms of numbers, and it is also spread well throughout the state and is found in all 4 ecozones, unlike some of the species which are restricted to only one ecozone. It is because of this that the chances of successful conservation for Egyptian vultures in Uttar Pradesh are quite high. Egyptian vulture, scientific name Neophron percnopterus, is a globally threatened raptor species. It has been classified as endangered by the IUCN. It is native to Europe, Asia, and Africa, and is a breeding resident in India. However, the population trend has been classified as declining. For this study, 8 species distribution models were built using the SSDM package, Stacked Species Distribution Model package in R. These are ANN or Artificial Neural Network, CTA or a Classification Tree Analysis, GBM, Generalized Boosted Models, GLM, Generalized Linear Models, MARS, Multivariate Adaptive Regression Splines, Maxent or Maximum Entropy, RF, Random Forest, and SVM, Support Vector Machine. An ensemble of these models was also built using the SSDM package. The input for any species distribution model are presence locations, climate data which have been sourced from WorldClim, and environmental data which in this study are land use land cover, LULC, elevation, and NDVI. The output of species distribution models are 3. The first are model evaluators. The second is the variable contribution of the most important model determinants. This is available in percentage. And the third is the heat map of habitat suitability. This heat map is available as a continuous range from 0 to 1. However, for this study, all the heat maps have been reclassified into 4 categories of suitability. Unsuitable, which is from 0 to 0.25, low suitability 0.25 to 0.5, medium suitability 0.5 to 0.75, and high suitability 0.75 to 1. This is a basic flow chart of the methodology followed. The occurrence data was collected through various regressive field surveys, which involved multiple road transects through which covered all the 4 ecozones. After collection of this data, it was further enriched by using published records, which included literature which is published in various journals, as well as the vulture census record from the Uttar Pradesh Forest Department, and also using citizen science data that was available from eBird. The other input of SDMs is the environmental and the climatic data, which formed a total of 23 raster layers. These were subjected to the Pearson correlation test with the threshold set at an absolute value of 0.7. And finally, a total of 12 non-collinear variables remained for this study. The occurrence data was also subjected to duplicate removal as well as spatial verification to remove any spatial bias that may exist in the records. Finally, a total of 333 unique presence records were run using the species distribution models. The outputs that were obtained were model evaluators of AUC, kappa, and TSS, and habitat maps and variable contribution tables. These are the habitat suitability maps obtained from 4 models: ANN, CTA, GBM, and MARS. All these 4 models for this study were categorized as inferior models. This was done based on one of 2 criteria, which was model evaluators or ground verification. The first criteria, model evaluators, includes AUC, TSS, and kappa value. According to researchers, any model with an AUC value of less than 0.7 is classified as a fail or unacceptable model. Similarly, any model with a TSS or kappa value of less than 0.4 is also classified as a failed model. So in this study, any model that scored in the fail zone for at least 2 of the model evaluators was not considered for further study. So as is clear from the table, ANN, CTA, and GBM were rejected on the basis of model evaluators. MARS, which has a good AUC value and acceptable TSS and kappa values, was also removed from the study on the basis of ground truthing, because it was found that it severely underpredicted the known habitat distribution of Egyptian vultures in Uttar Pradesh. It is clear from the map that compared to the other models, and also this was verified during various field surveys, that this model did not comprehensively predict the currently occupied habitat by the Egyptian vultures. These are the 4 models that gave acceptable values and results. GLM, Maxent, RF, and SVM had at least 2 model evaluators which are acceptable, and their prediction was also found to be acceptable and close to the ground value. However, even among these four, RF and SVM were the closest to the ground truth and had acceptable values for all three model evaluators. However, as we can see that there is no consensus and there is a lot of variability in the suitable habitat that was predicted. This is clear from the maps. Therefore, as it was recommended, an ensemble of these maps was made to come to the best possible prediction. And this map is the output of the ensemble model that was run. It depicts the four classes of habitat suitability. The purple color indicates unsuitable habitat, green indicates low suitability area, red indicates medium suitability area, whereas blue indicates high suitability area. This has been overlaid with a map of the 4 different ecozones. And we can see that the most suitable area is concentrated in the semi-arid ecozone. Here, it is important to point out that the boundaries of the ecozones that have been made using the political boundaries of the different districts within the state. However, it was noticed that the area adjoining the semi-arid ecozone, which falls in the Gangetic ecozone as per this division, has a climate, vegetation, and topography similar to the semi-arid ecozone. And this area in total is the area which is the most suitable for Egyptian vulture in Uttar Pradesh. The 3 model evaluators for the ensemble model were also accepted. And as we can see from the area as per suitability classes, in this table, 60% of the state is unsuitable for Egyptian vultures. However, at around 12% of the area, which is medium suitability and high suitability area, is found to be suitable. Now, this 12% of a large state becomes a sizable area of around 28,000 square kilometers, and this area must be focused on for conservation methods. This is an analysis of the variable contribution of the ensemble model. The top 5 most important variables that determine this model contribute 70% in model building. These are the top 2 environmental models are NDVI and LULC. The top temperature model variable is Bio 9, which is the mean temperature of the driest quarter, and Bio 8, which is the mean temperature of the wettest quarter. And the most important variable of precipitation is Bio 15, precipitation seasonality. Bio 1, which is the annual mean temperature, and Bio 14, which is the precipitation of the driest month, were the most insignificant variables and contributed to less than 5% of model building. There are some conclusions that can be drawn from this study. Primary among them is that RF, SVM, Maxent, and ZLM are all acceptable models. However, RF and SVM gave the results which are the closest to the ground truth, and therefore are the most acceptable among the 8 models that were run. The ensemble model was finally chosen as the best model because it is said to incorporate the positives of all the component models, and that is why this model was the one that was initially finally focused upon. The next important conclusion is that the semi-arid ecozone with its high temperature, low rainfall, tropical thorn forests, and ravine is the most suited ecozone for Egyptian vultures in Uttar Pradesh. The next important conclusion is that NDVI is the most important variable. This is also important because the NDVI has been used as a proxy for vulture food source in different studies by researchers. This is because the population of wild ungulates can be said to be directly proportional to the vegetation cover in the study area. Suitable habitat for vultures was also found in agricultural areas, and this indicates the ecological plasticity of the Egyptian vultures. This, combined with the fact that LULC is one of the top 5 model predictors, indicates a compatibility with human presence. This has also been verified through the field studies, as well as has been recorded in published literature that Egyptian vultures are likely to be found alongside river banks, on electricity poles, roadsides, and even garbage dumps, thereby indicating that Egyptian vultures may be found around human settlements. Finally, large swathes of moist deciduous forests, which are found in the Tarai ecozone in the northern part of the state, are also found to be suitable, and therefore these areas must be preserved for conservation of these species. Finally, this study has certain implications on conservation. These are in 3 parts. The first is in the highly suitable areas, which may be focused upon for in situ conservation. These areas can be used to declare a vulture safe zone or a vulture protection area. The second is the medium and the low suitability areas. These can be reclaimed in a way so as to bring them close to the highly suitable areas, and these areas can also be used for reintroduction of the species if this step is found feasible. Finally, these areas can also be used for ex situ conservation of Egyptian vultures. Even the unsuitable areas can be used for certain conservation methods. Primary among them is to provide food source for these birds. This can be done by encouraging animal husbandry in these areas, which are also largely agrarian. The other step that can be taken is to to enforce strictly the ban on NSAIDs such as diclofenac. For this study, I would like to thank the PCCF Wildlife for making vulture census records available for the study, and also the CCFs of Dudhwa Tiger Reserve, Wildlife East, Jhansi, and the DFO Pilibhit for extending their help and logical support during the survey and field verification stage in the study. With this, I would like to end my presentation. Thank you for your time.
Okay, thank you for video recording presentation. I'm not sure whether she hear us. Okay, she's here. So maybe we have 1 minute for Q&A. Any question? Okay, we have one question for you in chat box. You can read, or you want me to read for you? Okay.
I can read the question. They're asking for the ensemble modeling. Did you use all the models or only the acceptable models? For this study, I used only I used all the models that I had initially run, all the 8 models. And the reason for this being that in a few papers, it was recommended that this ensemble model will be able to capture all the positives of the component models. And for this reason, I used all the models to make the ensemble.
Okay, thank you for the answer. Okay, I think I would like to thank Radhika for the presentation just now. Okay, now let's move to our next presenter. I think Ashok Verma, are you here?
Yeah.
Okay, Ashok Wima will be talking on the winter ecology of Pallid Harrier Circus macrourus in northwestern India. Okay, okay, over to you, sir.
Yeah, let me share.
Okay.
Next slide. Presentation. I'm not getting my presentation. Can you help me?
There's a green button. You can green button, share screen button.
First, share screen.
Yeah.
Okay. Yes. Then I here.
Not yet.
Share.
We share and then you can select. Okay. Loading. Now I can see your desktop background.
Yes. Just opening. Is it visible?
Yeah. Okay.
Okay. I'm really sorry. Actually, due to connection, I got lost and I could not connect. Okay. So, good morning to everyone. My work is on a harrier, especially Pallid Harrier winter ecology in northwestern India. So let me introduce you the species of harriers we have in India. We have Western Marsh Harrier, East Marsh Harrier, Pied Harrier, Hen Harrier, Montague's Harrier, and Pallid Harrier. So this is the greatest biodiversity post-breeding in India. This is not only in India, I think all over the world, this is the largest post-biodiversity. So I concentrated on Pallid Harrier, and it was one of the very difficult group of raptors. They're very special in the sense they roost on the ground and they breed on the ground. So here you have a female, and this white band is clearly visible, and this is the juvenile, where this is all brown and no band is present. So it's very difficult when they come in during the roost and you have to count them. So it makes one of the challenging tasks to count. And you see the male is bright color and easy to identify. So what I did was I collected information on roosting habitat, roosting behavior, population structure, winter diet, foraging movements, migration journey. And I use road transit methods to travel most of the parts of my country, especially in Rajasthan and Gujarat, which is northwestern part of India. So first I traveled, and then suitable areas were surveyed using camel, cars, and on foot. Once the roost was identified, I counted the birds from a vantage point. And I also use misnat and other local methods to trap the harrier. And I put the satellite transmitter also to track their migration route and foraging movements from roost sites. So here are my results. Very interestingly, what I found was they pre-roost before roosting, and they use trees, stumps, and on bare ground. Harriers are generally don't use trees, but here they're using trees. They spend considerable time pre-roosting, communicating each other, vocalizing, and sitting quietly, preening. They use trees as of height 8.9 meter for pre-roosting. So these are the roost sites which I could identify, like the bare grounds are the most favored roosting sites. But during stress, they use wetlands with floating vegetation, especially water hyacinth. And here, if the grasslands are not available, they roost on the bare grounds also. Like in Gujarat, where salt pans are being used for roosting, but but here the grasslands in Gujarat and Rajasthan are the favored habitats for them. But as I said, during stress, they also go to water hyacinth and wheat field, as shown here. It was very challenging to find out its roost site characteristics because they generally found in groups. It's a huge communal roost of 2,000 harriers in Gujarat, and pointing out only Pallid Harrier is very challenging. So what I was looking for, the exclusive roost of Pallid Harriers, and I could get 6 individuals together roosting. So in Rajasthan, they use their 1.2 meter tall grass, and Whittivaria zizinoides 2.8 grass, the second grass. So it was like a platform. They were sitting on the soft grass and protected by Whittivaria zizinoides, which was very hard or strong grass. And the former formed 92% of the roost habitat. It means the Desmostachia bipinata. The individual roost site was about 1.4 into 1 meter long and wide. Harriers roosted alone, maintaining 50 to 200 meter distance between each other. It was located about 122 meters from road, 450 meters from wetland, 140 meters from agricultural land, and 1 kilometer from human settlement. When I see the individual roost site, they use from 3 to 34 days continuously the individual roost site. And the female, they use continuously for 12 days, and the other female for 4 days before it departed on 19 March. So they depart from India on March, and male harriers, they continuously roosted on 3 days, then 5 days, and third male for 27 days, and it departed on 8 April. And the juvenile was using that particular site for 34 days, and it departed on 24 April. So here, the sites which I investigated for pellets, I found male sites with fresh pellets 44%, sites with excreta only 33%, sites with no pellets and excreta 22%, and juvenile sites with fresh pellets 37%, sites with excreta only 51%, and sites with no pellets and excreta 11%. So this shows that they are not regularly pelleting out, but probably they go to their foraging ground and they pellet out. So these are the pellets. So the prey, what I found from my small sample, male used 54% birds, small birds, rodents 39%, reptile 5%, and juvenile 50% small birds and 50% rodents. And because I could not collect exclusive pellets of female, so of 41% pellets, I have a female pellet also. So it was 69% small birds and 31% rodents. Now I will tell you the population fluctuations in Gujarat, which is the largest roost all over the world, where 2,000 individuals of harriers of 4 species, hen harrier, Pallid harrier, Munchausen's harrier, and marsh harrier, they roost in the grassland. So here, if you see, male comes in September, then population increases, then it again increases to 160, and then they drop down. And it is similar with the juvenile, but female, September, population is there, then October, then November, and December it increases. When the population of males decrease, probably they go further south to South India and up to Sri Lanka, and the female remains here as wintering birds, and the population increases. So we have 2 populations. One is the wintering, and other one is the staging, which remain here for some months, and then they go further down. So now up to the luckily one Pallid harrier, it is male juvenile. It was fitted with back power, solar powered PTT in 2008, and it was very difficult to catch them from roost. I tried a month and I could catch only one with the mist net. So important data I got was it spent 2 weeks foraging nearby areas up to 15 to 25 kilometers from the roost. So we were thinking that their only home range is very small and they are concentrated in the grasslands only, but it is not. They go to field areas and up to 25 kilometers. So now this is the route, the migratory route in spring. So if you see here, March, I caught one bird, then it goes to Pakistan, touching the border, and then again it comes to India, and then it goes to Afghanistan, then Turkmenistan, Uzbekistan, and here Tajikistan. So in 22 days, it covered more than 3,700 kilometers of distance with 2 stopovers, one in Pakistan and one in Afghanistan. And with a speed of 277 kilometers per day, it reached from India to Kazakhstan. And from there, it summered for up to 21st July. And then it went further 950 kilometers to Russia. And probably they breed there. So this is first time that we came to know that our population of harriers goes up to Kazakhstan, Siberia, and they breed there, and probably they come back. But we lost in September the battery, and we could not get the route of return journey. So this is where they spent summer. Here, this is the summer. The juvenile males spent the summer, and then it went up to here, Russia. So the survival threat, which I think is that conversion of grasslands to agricultural land is severe. And then cattle grazing in the root sites also very prevalent. And the protected areas the government protect is not sufficient. They should look for other areas outside the protected areas. And also grass cutting in the root sites by local community. They are given permission, and it is thought that grasses are just wasteland, and it is not meant, there is no conservation value or importance of harriers for locals, and there is lacking awareness on the importance of harriers. So they come in the park and protected areas, they cut the grass so that they disturb the roosting habitat of harriers. And that's why they shift to wetlands on the floating vegetation and croplands where they're susceptible to many disturbances, many threats. Like they have jungle cats, they have pythons, maybe jackal. And second, what I found was the invasion of exotic species like Crossbreed julifera is fast spreading to the grasslands, so that need to be checked. And of course, pesticide injection through prey could be another threat. I analyzed some of the pallets and tried finding out the amount of pesticide. It was negligible, but the sample size was very low. And of course, as I said, lack of awareness of harrier importance is there in public. I'm thankful to your attention, and I want to acknowledge Ministry of Environment who gave me the permission, Wildlife Institute of India, Forest Department of Gujarat and Rajasthan, Geographic Foundation, Natural Research Limited, BR30, Thomas Cornelier for helping me in trapping the harrier, and ARRCN who encouraged me a number of times to conduct my work in India. Thank you very much.
Okay, thank you very much for your presentation, Mr. Verma. So now I would like to open the floor to question. So we have one question for you in the chat box. So what is the difference in behavior between pre-roost and roost?
Okay. See, pre-roost and the roost, in pre-roost, they check if there's any predator present, like jungle cat, jackal, and they sit in the open. They probably communicate with other harriers, their other individuals. Probably they remain in small families, so they wait for them and they roost together. So first, they sit in open and look for their members to come in, and then they go together, they soar together, look for any predators in the grassland, and if they think that it is safe, they drop down into the grassland. So that is actual roosting, and before that they do pre-roosting. Is it clear?
Okay. Any other question? So one question from lempiji. How many days at stopover site?
Sorry, how many?
How many days at stopover site? Stopover site. So you can read in the chat box.
How many days at the stopover sites during spring migration?
Okay. Yeah, lempiji.
Thank you.
The harriers at stopover site in Pakistan, it stayed for 3 days, and in Afghanistan over 5-6 days. In the desert, Afghanistan, and in Pakistan, it was I could not get the habitat data, but before it crossed the mountain peak, that is just 2,000 meters, it stopped somewhere in Pakistan for 3 days.
All right, thank you, Ashok, for your interesting talk about harriers. I love harriers.
Yeah.
Okay, we have one more question in the chat box here. From Yani Lu. Is there any vocalization during pre-roost to attract family members?
Is there any vocalization during? Yes. They become more vocal during pre-roost. Actually, it is earlier thought that they don't vocalize, and I found many kinds of vocalizations, and they fight over the pre-roost perch also, and then a number of times they settle and resettle on the pre-roost perch, and also when they soar over the roost side, they communicate vocalizing number of times, very shrill call, and if they find any predators, they all together mob the predator from the roost side. In that, not only Pallid harrier, but many harrier species, they come together and they drive down the predator.
Okay, thank you. I hope that answers the question. So, okay, thank you for the answer. So I would like to thank Ashok Verma for the presentation, for a great presentation and great findings. Okay, all right, okay. Now let's welcome our last speaker, Krishna Prasad Busal. So for the next presentation, it's also a recorded presentation. Okay, so he will be talking on population levels and productivity of the critically endangered white-rumped vulture are stable in Arghakhanchi District, Nepal. Okay, we can start play the recording.
Hello, namaste everybody from Nepal. I am going to present about the population level and productivity of the critically endangered white-rumped vultures in Nepal, especially after the diclofenac bannings in the cattle treatments. So my name is Krishna Bhushan. I did the work on the vultures more than a decade in the bird conservation Nepal, wildlife partner in Nepal, and also involved in the saving Asia's vultures from extinction. This is the consortium of the scientists, different organizations, and the government authorities to save the globally threatened vultures in the Asia regions. And also I am a member of the ARRCN Species Survival Commission, the vulture specialist group. So today I am going to present about what actually the changes on the populations and productivity of the vultures in Nepal in the last decade. So it is just telling about the background of vultures and its relation with the cultures. So in the Hindu mythology, it is quite good attachment with the vultures. In the historical, some of the incidents like the Ramayana actions in the Jatayu. So you can see the pictures. There is the Ravana who kidnapped the goddess Sita, and the vultures, that is the Jatayu, that is fighting against the Ravana to make free the goddess Sita from the kidnapping. So it's something like that. It is fighting against the terrorism or something like that. So some people are mentioning something like that. So this picture from the Nepal, it's in the Trans-Himalayan regions of the Nepal and Tibetan cultures. There is the sky burial practices. The people chop down the pieces of the dead body of their relatives and to feed the vultures. So it is still the life practice of in these Trans-Himalayan regions, and in the Trans-Himalayan regions there is no enough food to firewood to make the ceremony or something like that, and the land is also fragile. So in these cases, the dead ceremony or something like that, the ending of life is also related with the vultures, and the people believes that the body who is quickly finished by the vultures is something good. Who is doing something good job in his life or something like that. So it is also the living cultural practices in the Trans-Himalayan region of the Nepal and the Tibetan regions. So the most of the important things is that there is the strong ecological importance or ecosystem services of the vultures that feed the carcasses in the short duration of the time periods, and they prevent the spread of some of the zoonotic disease and control some of the pollution in the nature. So we popularly call that the vultures are the natural scavengers. So they have the important ecological role, ecological service in our nature. So this is the some background scenario of the 1980s. So the people think that the vulture is one of the most abundant and easily seen bird at that times, and there is some of the estimated populations, something like that. The India that holds the 30 to 40 million pairs of the vultures in that time, and Nepal also holds the 1 to 1.16 million individual at that times. But this is the history. The scenario is not same for a long time. So in the decade of the 1990s or in the early of 2000s, the population of the vultures is declined dramatically in the Asian regions. So for example, in the Nepal, the population of the white-rumped vultures and cylinder-billed vultures, both are the critically endangered gypsy species of vultures that declined more than the 90% in between the 2002 to 2011. So this figure shows that the population of the gypsy vulture, especially the white-rumped vultures and cylinder-billed vultures, And in India, that is the long-billed vultures declined more than 90%. And in the world record is in India, the population of the white-rumped vultures is declined more than 99.9% from the in between the 1990 to 2007. So it is very devastating scenarios, and it comes down to the very small and very localized populations. So in the 1980s, we think that the population is more than 1 to 1.6 million, but now we have around the 20,000 individuals, and the most of the birds are critically endangered globally and nationally. And some of the birds number is the more than 100, less than 100, so something like that. The cylinder-billed vultures, that population, estimated population is only the 50 to 75. So it's very small, the remaining population of the vultures are remaining in our country and probably in our region. So the main cause of the decline is the diclofenac. This is the well-known and well-documented things. That the diclofenac is the painkiller to the cattle or in the livestock, but it also kills the vultures. So it makes the very quick recovery to the cattle or livestock, but it makes the renal failure to the vultures. So the vultures are actually the feed in the large group. So the only 30 ml vial of the diclofenac can kill the 350 to 800 individuals of the vultures. So it may make a large number of the loss of the vultures in these regions. So this is the painkiller to the livestock, but it is the killer to the vultures. So in response to the vulture population declines, there is some of the major responses which has been adapted in the Nepal. So that there is the Vulture Conservation Action Plan that guide that guide to implement the vulture conservation actions to the ground level. And it is the policy document. The diclofenac is banned in 2006, and there is the very integrated approach to remove the diclofenac from the use and in promotion at the same time in promoting the safe alternative of Melxi camps. There is the community managed Jatayu restaurant, popularly called the Vulture restaurant, that feed the safe food to the vultures. Pharmacy monitoring, the undercover and open survey, and that is beginning the diclofenac free zones, to making the area actually the diclofenac free. This is also initiated the captive breeding programs. So the Vulture Conservation and Breeding Center is established in Nepal, and after the successful captive breeding, it is initiated to release into the wild from 2017, and it is some of the good progress. That is the annual survey of the vulture colony and the transit, and also at the same time monitoring the birds through the satellite taggings and monitoring through the satellite tags. So these are some of the major responses in order to halt the population declines of vultures in Nepal. So it is just briefing about the some of the key highlights. This is Jatayu restaurant or Vulture restaurant. It is popularly called the safe food supply stations. In Nepal, there is the 7 safe food supply station, and that feeds the safe food to the vultures. And these are the actually ARRCN is the dissemination of the information about the vulture conservations, and it also promotes some of the tourism. So you can see that there is some of the activities of the 1, 2, 3, 4, 5, 6, like that. Some of the old and unproductive cattle collected from the farmer, and they kept in the cow sheds. And after the natural death, the people feed the carcass to the vultures, and the people can watch from some of the watchtower, as mentioned in the number 4, and that also promotes the ecotourism. So it is some of the good models of the participated conservation of the vultures in Nepal. And also we initiated to making the area the diclofenac free zones. So till the date, more than 74 districts are declared the diclofenac free zone. So you can see that some of the all the highlighted parts are already declared the diclofenac free. It was initiated from 2010, and it takes a long time to make the whole area as a diclofenac free district. So it's just some of the good example. So it's worked with the district level stakeholder and community to make the diclofenac free in the livestock treatment. So what happened after that? So this is the major highlight of these presentations. So from the road transit survey from 2002 to 2020, or up to the 2018 that is presented here, it shows that the blue dots of the white-rumped vultures and the red dot of the accelerated vultures, both population is declined more than 90% in between the 2002 to 2012 up to 2013. So after that, the population of the both Gyps species is going to upwards. This is very, very good news and very huge success. So when the diclofenac is banned in 2006, that takes the, quite more time to remove the diclofenac in the cattle treatment. So it takes about the 5 to 6 years because the diclofenac is quite popular drugs in the cattle treatment. So most of the people are love to use that drugs in the cattle treatment. So the legally and somehow illegally the drugs is supplied up to the many more years of the banning. So it takes the quite long time, but after the removal of the diclofenac in the livestock treatment, it actually reflects in the increase in the population of the vultures. So it is the good example of this from the target or to save the vultures in Nepal. So and that is the good news. And another highlights that I'm going to present about here is we also studied some of the isolated colony of the white-rumped vultures to know about the breeding success and their the population level in the nesting size. So we monitor some of the nesting colony in the Arghakhanchi districts from 2010 to 2021. So it presents about the 12 years data of their colony monitoring and their analysis of their breeding success. It shows that the productivity and population level of those critically endangered white-rumped vultures in the Arghakhanchi district is stable. So it is more than good news because the population of the critically endangered white-rumped vultures declined more than 90% in the past decades. But now its population is going up, and at the same time, the productivity and population level in the isolated colony level is also okay. So it shows that the removal of the diclofenac from the livestock treatment and working in the integrated approach with the partnership with the community, stakeholder, government, non-government organization, and many more. So it makes the changes. It makes the good result in the conservation of the vultures, especially the critically endangered white-rumped vultures and accelerated vultures. So now I recommended that this is somehow the short period study because the vulture is the quite long life birds. It can live more than 20 years or around the 20 years. So we need to study the long terms to know the activity, productivity, and population level. But it shows that there is the positive changes, positive things we have received, and it shows some of the good example of working is as creation of the vulture safe zone, that is actually the safe zone to vultures resulted into or impacted into their population level and as well as their productivity level. So thank you so much for listening that, and this is achieved through the many more partnerships from the government level to the NGO level, and is actually from the community level. So thank you so much for listening this. Thank you so much.
Okay, thank you so much for video recording presentation. Now I would like to open the floor to question. I think Mr. Krishna Busar is here to answer.
Yes, I am here.
Okay.
Please.
So any question from the audience? Okay, we have one question for you here in the chat box. You can read. You can read it?
Yes.
Okay.
Yes, the sky barrel practice is
still live in Nepal and in the Tibetan region, but it is very limited now, and it is somehow related with the decline of the vulture population in the Trans-Himalayan region. So some of the people, local people, shifted to that ceremony, to the options. But it is still in practice in the Trans-Himalayan region in Nepal. Thank you.
Okay, thank you. Any other question from the audience? We have some time for Q&A, about 2 minutes. Okay, if no question, I would like to thank Krishna Bhusal for the presentation. Okay, so I look like we have covered all of the presentation today for this morning. Okay, so well, we have come to the end of our session. So I guess that's it from me. I would like to conclude by thanking the presenters for their sharing and presentation, great presentation. I would like to thank also to all participants. So I think now I pass back the session to the organizer, or maybe you can join the other breakout room, because maybe their presentation is still ongoing, or you can wait for the next session to start.